many of you are doing ultrasound? Please raise your hand. Okay. How many of you are doing ultrasound since 1 decade? I mean 10 years. Is there any? 1. Don't hesitate now. 2. So how many of you are doing ultrasound since 5 years? Okay. Who is a fresher here? So about a 40% are 40 to 50% are freshers. Thank you. About a half of candidates are freshers, but half are doing ultrasound. Some 2 years, some 5 years, somebody for a decade. What an ultrasound is? Can you give me the definition of ultrasound? What is ultrasound? The definition of ultrasound. Now see, first of all, be clear that you have to pass, not you have to pass. If you want to work in US, you have to pass an exam, and that is ARDMS. There, they will not be asking whether you are having this much of knowledge, this much of degrees. No, they will tell you, come and crack this exam and work in the US as a sonographer. They call it sonographer. But most of the Indian doctors are failing over there. Why? Even after doing ultrasound for 2 decades, they are not clearing that exam. Why? Because first part is physics. After clearing the physics, you will be giving the part 2, and that is your specialty. Now, this is the board type question. What is an ultrasound?
It's a sound wave.
It is a sound wave. Okay. What is the definition of the sound? Mechanical longitudinal wave. Please note it down. It is a mechanical longitudinal wave. When I say longitudinal, what I mean by longitudinal? Now see, whatever in books you are seeing, the sound wave is the graphical representation of compression and rarefaction. We will draw all these here. That wave is not traveling actually like this. This is the graphical representation of compression and rarefaction. Now, I'm giving you the highlights, what you have to, go through in that physics. What is the wavelength? Now we are going back to 9th standard right now, but this is important. What is wavelength? Distance between 2 points in a wave, 2 identical points, I will say. That is the wavelength. Now coming to your probe. In your probe, if you are having a high frequency, this is board type question. If you are having a high frequency, what is happening with wavelength? Is it decreasing or increasing? Decreasing. It is because of the decrease in the wavelength that the high frequency probe is not penetrating. What I am trying to do is the correlation of your physics with this ultrasound. So at least have a basic understanding of this physics. Okay. Now, when we talk of a convex probe, this one, convex probe. In this convex probe, what is the frequency? How much is the frequency?
3.5.
So roughly it is in between 2 and 5 megahertz. What this mega means? Million. So million of hertz are there in this convex probe. Now see, this is the convex probe. Abdominal probe, okay? But in your TVS probe, let's say not TVS, but a linear probe. Linear or a TVS probe, okay? How much is the frequency over here? So about a 10 and more, right? Now, if I put this probe onto my abdomen, can I see the gallbladder? No. Why? So here comes the penetration issue. Now see, penetration versus resolution. Now, if resolution is more, now try to understand. If resolution, what is deciding the resolution first? Resolution is deciding by what? By that frequency. And that frequency is decided by that wavelength. Are you correlating the things? Now, when I am having a high frequency probe, the resolution will be more, but penetration will be less. And vice versa. Now, what is this 2 to 5? I am holding a probe. Is it having 2, 4 or 5 megahertz? This is the bandwidth. Now see, this is the bandwidth. So this probe frequency can be changed between 2 and 5. Now, if patient is obese, then you need more of penetration?
Yes.
Yes. It means that what you have to do with this frequency? Decrease? Are you understanding? Freshers. Now, if I don't need penetration, if patient is thin, if I don't need penetration, then I can increase the frequency this way. I can increase it up to 5 without changing the probe. But the point here is that with increase in the frequency, what will happen with resolution? Resolution will improve. This is the correlation of your physics in this ultrasound. Without this, you cannot make use of these knobs. Without this, your money is getting waste. You are spending a 1 CR on machine, but without this physics and knobology, your money is getting waste. You can do wonders with a simple machine conditioned to the knobs. Your machine is born blind. Your machine is a robot. Your machine cannot see. Try to understand. Your machine does not have eyes. You have to put your eyes, your brain in your machine, then only machine will work. By giving a command, we will come to this knobology. You are rotating a knob, clockwise, anti-clockwise, pressing here and there. You are actually giving command to machine. Machine, do this, don't do that, do this. For example, this frequency, you are rotating it clockwise or anti-clockwise. But machine is born blind. And machine does not have brain. Machine is designed in a way to follow your commands. You are actually giving commands to machine. But if you don't know what command to give, your machine is taking, I have to obey, is obeying actually. Now, for example, you give a wrong command. By wrong command, I mean you don't rotate it clockwise, but anti-clockwise. By anti-clockwise rotation, what you are doing? You are decreasing the frequency. Actually, you need to increase the frequency. Then only the resolution will improve. Then only the picture will, you will have a good quality image on your screen. So machine will not work unless and until you will not put your eyes and your brain in machine. People are cursing the machine. अरे डब्बा machine, मेरे को gall bladder में stone दिखा था. When surgeon operated, it was clear. It is not that you have to curse the machine. It is because that you have given wrong commands to machine, then machine is giving you that picture as per your command. But you don't, better not to press the knob if you don't know the function of the knob. But on the same note, why you are buying this knob then? You are actually buying these knobs. By 50 or 1 CR, what you are doing? You are spending your money onto these knobs, then these knobs remains untouched. I'm 101% sure, 101% sure that whosoever is doing ultrasound, even for a decade, is not using all knobs. Am I right or wrong? Yes. Then why you are buying this type of machine? Go for a lower version. But you are assuming, you are thinking that by spending more money, you will get a clear image. No, you will not, unless and until you are not knowing the basic of the physics and your knobology. Okay. Now, don't skip the first topic, and that is the physics. If I will keep on talking of this physics, ultrasound physics, it will take about 5 days. 5 days. But if I continuously keep on going, you know what will happen. So I will in between give you half an hour, tomorrow 20 minutes, day after tomorrow. So in between we'll be talking of this physics. And request to you is to have a good book. Any book is good book. I have written 5 books. Don't go for my books. Any book is a good book. And please go through the basic of the physics. Don't skip the first topic. Don't start from the second one. Now, Dr. Jyoti will come with the class of knobology. Okay?